Okay, we're going.
Okay.
Okay, do you want me to go ahead and read question 3?
Yep, go ahead.
Okay.
Okay, question 3. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? And the options are right skewed, normal, or skewed left. And that is skewed right.
I
was
got the
a-
same.
That was a tough question.
I hope they're all that tough.
Yeah. Yeah. Me too.
No, I went through and looked at them. They're really actually pretty easy. You go pretty quick.
Okay. So I'll take number 4. When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
That approaches normal after you hit 30, right?
Yeah,
Yep.
because it's a large sample size.
Yeah.
Mhm.
Okay.
Okay, I'll do question 5. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? I put normal because it's taken from a population that's normally distributed.
Yep.
Makes sense.
I agree.
Okay. When you're taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed?
Normal.
Is that normal as well?
Yes.
Yeah.
Okay, cool.
Okay. Question 7. When would the distribution of means be normally distributed? Choose all correct responses. Data drawn from a population that is normally distributed and the sample size is small is correct.
Mhm.
Data drawn from a population that is normally distributed and the sample size is large. That's also correct.
Yep.
Data drawn from a population that is right skewed when the sample size is small, that would not be normally distributed.
Mhm.
But data are drawn from a population that is right skewed when the sample size is large, would be normally distributed.
Yep.
Yep.
As far as the distribution of means goes.
I think the same way.
Okay, so the last one is also true. Data are drawn from the population.
Yes.
Okay.
Yes.
Mhm.
All right.
Okay. Which of the following gives the best explanation of the central limit theorem? A, if the parent population from which the data are drawn, then the sample means X will follow a normal distribution. For bell-shaped data, approximately 68. So that's the 68, 95, 99 rule. And then C, if the sample size is large, the sample mean of X will be close to the population mean. And I forget the word for that, mu. I don't know.
Yeah.
If the sample size is large, the shape of the distribution of sample means will be approximately normal.
I think it's that last one because number 2 is obviously not it.
Right.
That's what
I was going to
Yeah.
say C or D. D?
the one above that is actually the law of large numbers.
Yeah.
Oh, yeah, you're right. You're right.
So we all agree on D?
Yeah.
Yep.
The last one, I mean?
Yes.
Okay, cool.
Okay, I'll do this one. Let X be a random variable with a population mean of mu is equal to 10, a population standard deviation sigma equals 6. Suppose a sample size n of 36 is drawn from this population. What is the mean of the distribution of the sample of means? I put 10.
That's
How
what
how do we calculate this one?
well, you're okay. You're
Oh, what is the
looking-
mean distribution? Okay, so we just
Yeah.
use.
So it's kind of the same as on the homework or on the preparation. There was a question. Well, I think it is the homework actually. They asked a question similar to this, and it was
Okay, so then it,
population reflects the sample distribution means given a large enough sample size. That's why I
Okay.
chose 10. but I'm open for debate.
Okay.
I see what you're saying. Because it's over 30, you're saying that it would be identical to the regular population mean,
Or very close to the population.
or very close. Yeah, that makes sense.
Sample size is 36.
Okay, let's put 10.
Okay. Question 10. What is the standard deviation of the distribution of sample means? As it's a larger population, will get closer to that, but I think since it's normally distributed, it'll still work because it's not a super large population.
So there's actually a form. Sorry, there's a formula for this one.
Oh, sweet. That's right. Isn't
So
the
yeah.
distribution divided by the square root of the n?
It is. So yeah, sigma divided by the square root of the sample size. So
So it's 1.
yeah, it's 1.
Okay. All right. Read that next one. Regardless of the distribution of the population, if the sample size is large and is greater than 30, what would be the shape distribution of the distribution of the sample mean?
Normal.
Normal, yes.
Simple large, yeah. 30. Okay.
And then
12. What theorem would justify your response to the last question?
so the
Law
law of large numbers.
Yeah.
Is it the law of large numbers?
I would think so,
Yeah.
because the central theorem law is
Talking about the sample
sample
mean.
distribution will be approximately normal if the sample size is sufficiently large enough.
Okay.
Yeah, it says if the sample size is large.
But
This what would be the shape distribution of the distribution of the sample mean.
wait
The
a
law of
second.
large numbers states that the
No. If the larger the number it gets, the closer your sample, the smaller your deviation will be. So that
Yeah, so
actually is the central limit theorem.
So I pulled up the central limit theorem here, and it says the central limit theorem is a statistical theory that states that given a sufficiently large sample size from a population with a finite level of variance, the means of all samples from the same population will be approximately equal to the mean of the population. So this is just saying, say you have something bigger than 30, then the mean of that sample will be roughly the same mean as the parent population.
Mhm.
So that's the one we used for question 9.
Right. Whereas the law of large numbers just has to do with the distribution, whether it's normal, right skewed, left skewed, that whole deal.
Okay. That makes sense to me. I think that's the last one. I'll go ahead and submit it and see what we got, see if we got anything wrong.
Okay, cool.
Yes, I want to submit the quiz. Weird how many times you have to click submit.
Yeah, seriously.
Give it to you.
Thought that too.
And question 12 is not accurate with the law
Oh,
of
really?
large numbers. It is the central
Really?
limit theorem.
Odd. Okay, then I guess I just totally did not understand that.
That's all right. Yeah, all the rest of them are right though?
Yes.
Okay. Do you need us to read them off for you, Nathaniel?
Just a second. I'll see if I can get there. Okay. Okay. 8. If that's the sample size is large, let's say, well, actually approximately normal, right?
Right, the
Yes,
last
so
option
it's-
there.
Okay, and 9 was 10,
Mm-hmm.
and 1,
Mm-hmm.
normal, and then central limit theorem. Okay, if one of you would submit it just to make sure I didn't miss one on that.
I ready, and it's all good. When we change 12, it's all good now.
Okay, right, same on mine.
Sounds good.
That was a quick one.
Yeah, no kidding.
Hopefully the next one's similar because it's another building stage from what the Brother Polson sent out. This week's more of a generality things than actual formulas, which is just fine with me.
Yeah, that's completely okay with me too. Huh.
Mhm.
And curious, when did we want to have the next meeting?
Wednesday would be best for me. I cannot
Wednesday.
do it Thursday.
Okay,
Right.
so Wednesday at 9.
Yes.
Yep, that
Okay.
works.
Perfect.
Sounds good. I'll see
right.
you then.
Okay,
we'll see
thanks
ya.
guys. See ya.
Thanks, guys.
Bye.